All right, good morning, everyone. Today we are doing long division and synthetic division with polynomials. So go ahead and take out your notebook, write some of this stuff down. The worksheet for today has both long division and synthetic division on it. The front is long division and the back is synthetic division. So we will be just doing long division today, and then tomorrow we'll do synthetic division, which means your assignment for today, Thursday, is um, long division. So you'll just do the front, and then tomorrow you will we'll add synthetic division and you will do the back. Okay. So before we get started, we just need to review a little bit about what long division looks like. So if you remember the parts of long division, the dividend is the part that is being divided, and the divisor is what you are dividing it by. The answer is called the quotient, and then if we have a remainder, we add it on to the quotient and we put it over the divisor. So that's just a quick review of that. Let's just do some long division just with numbers first, just to remind yourself what it looks like, and then we will do some with polynomials. So first one here, we have 13 divided by 2,314. So remember, the first step for long division is to look at 13 and this first number. We know it won't go into 2, so we're going to scoot over to 23. How many times will 13 go into 23 evenly without going over is what we're looking at. So it goes in 1 time evenly. So we put the 1 above the 23. 1 times 13 is 13, so I'll place that number underneath. And 1 times 13 is positive 13, but we want to subtract it from the number above, so we're going to put a minus right here. So 23 minus 13 is 10. And then I bring down the next number, 1. So now I'm looking for how many times does 13 go into 101. I would estimate about 8 times, but go ahead and check it on your calculator. But it turns out that 13 times 8 is 104, not 10, and that's over 101, so we've got to go down to 7. And then 7 times 13 is equal to 91. Oop, oop, oop. 91. Now I'm going to subtract that from the number above. 101 minus 91 is 10, and then bring down our next number. So 13 does go into 104 8 times, so we put 8 up here, and 8 times 13 is 104, which I put down here. Okay, and because I get a 0 here at the end, that means there's no remainder. It goes evenly in 178 times, so that would be the answer to that one. All right, on our second problem here, we have 3,125 divided by 6. We need to write this in this other form so that we can use long division. So the divisor, 6, goes on the outside, the dividend goes here. All right, so how many times will 6 go evenly into 31? And since 6 times 5 is 30, we'll put 5 here, and multiply them to get 30. Then we're going to subtract 31 minus 30 is 1, and bring down the next number. Now we're starting over a little bit, so 6 goes into 12 2 times, so we'll put a 2 up here, and 2 times 6 is 12. Subtract it from the one above, we get 0, and bring down our 5. All right, 6 goes evenly into 5 0 times, so I'll put a 0 up here, and then multiply them to get 0. Subtract them, and now this 5 right here is my remainder, so I would add on 5/6 to 520. So the answer here is 520 and 5/6. All right, so now we're going to take and apply this to polynomials. So the method is a lot the same. There are a few differences, but we're doing that general long division, the general long division steps the same way. So let's write this out in our long division form. All right, the first step is just to look just at the first term here and just at the first term here. So I want to think about how many times, or what would I need to multiply x by in order to get x squared. And because x times x equals x squared, x is going to be the first number I put up here. I'm going to keep things with the same exponent in a row, I guess. No, a column. And so because x times x is x squared, I'm going to put the x above 4x because they have the same exponent, right? Which, if I don't see it, is a 1. Now I'm going to take x, just like I did in regular long division, and I'm going to multiply it by the divisor. So x times x is x squared, and x times -1 is negative x. So that x does need to be multiplied by both terms in our divisor. So now I have a polynomial under here, x squared minus x, and I need to subtract it from the one above. When you subtract a polynomial from another polynomial, remember that negative will distribute to all the terms. So this would actually be minus x squared and then plus x if I distribute that negative inside. So x squared minus x squared is 0. That first term should always go to 0. If it doesn't, it means you made a mistake when you found your first part of the quotient. So make sure that that part goes to 0. And then I'll go ahead and add 4x plus x, which is 5x, and bring down my next term. So now I need to kind of do that same process again. I'm looking just at the first term, x, and I'm looking at my new term, 5x. I need to think about what I would have to multiply x by in order to get 5x. And that is 5. So I'm adding it on. If it were negative, I would be subtracting it. But we need to make sure we have a plus and minus between each term up here. So that's one of the differences between this and regular long division. So now I take this 5, just the 5, and multiply it by x minus 1. I need to make sure I multiply 5 by x and by -1. So that would become 5x minus 5. And remember, I need to subtract this polynomial from the one above. So if I distribute that negative in, it's negative 5x and positive 5. And that one should go to 0, and it does. And negative 3 plus 5 is equal to 2. Now this 2 is now my remainder. So I'm going to add 2 over my divisor, which is x minus 1. So my result here is just x plus 5 plus 2 over x minus 1. All right, let's try another one. Come on, advance to the next slide. Ugh. Okay, so we have 5x squared minus 1 divided by x plus 1. Now, when you're doing long division, you have to make sure that your x's go down in order. So since this has x squared, my next middle term should have just an x. But because it's missing, I'm going to write it as a 0x. Okay, so that's because I should have my answer in standard form and I should not have any x's missing. It should go, the exponent should go down in order 2, 1, and then no x. So remember, if I don't see an exponent on x, it's 1. So I need this placeholder of 0x1 here. So anytime you are looking at one of these problems, double check your exponents and make sure that they go down in order, because if they don't, then you need to put a 0 in there to hold your place. I'm just going to try that again. That looks crazy. Okay, so the next thing we need to do is look at just the first term. Come on, give me my pen back. We're going to look at the first term, which is x, and we need to think about what I would have to multiply x by in order to get 5x squared. So I'm looking just at the first term here and the first term here. In order to get 5x squared, I would have to multiply x by 5x. And again, I'm going to put that over the other x, that's to the first power. So 5x times x plus 1, remember I need to multiply it by both terms. So 5x times x is 5x squared, and 5x times 1 is 5x. But remember, I need to subtract this polynomial from the one above. So this becomes negative 5x squared and negative 5x. So that becomes a 0. This becomes negative 5x and then I bring down my next term, which is -1. Start the process over. I'm looking at -5x and x. In order to get -5x, I would have to multiply x times -5, and then multiply it back, so -5x minus 5. Remember, I'm subtracting this, so I need to change both the signs there. So that goes to 0, and this way I would get 4. So that 4 now is my remainder. So I would add this on 4 over x plus 1. So the result here is 5x minus 5 plus 4 over x plus 1. All right, one more. Not cooperative. There we go. All right, so we have 2x squared plus 7x minus 15 divided by x plus 5. Just 1 second. Okay, I actually skipped ahead to the next problem because I only want to do one more example, and I want to do this one because it's a little bit different. So notice here that I have my x to the third last. I have 3x squared over here. I need to make sure this is in standard form before I begin. So I'm going to rewrite the order. Well, let's do it up here. So x to the third plus 3x squared minus 4 would be in standard form, because remember, in standard form, highest exponents first, second highest, and then to lowest. And notice here that I also have that x term missing again, so I'm going to write this as x to the third plus 3x squared plus 0x minus 4. And then I'm dividing that whole thing by x minus 1. So again, I start with the first term here and here. What would I have to multiply x by in order to get x to the third? And that would be x squared. Now take x squared and multiply it back by the divisor. So x squared times x is x to the third. X squared times -1 is -x squared. We're subtracting this from the one above, which would change the signs of each term. That goes to 0. 3x squared plus x squared is 4x squared. I would bring down my 0x. So now I'm looking again at x and 4x squared. I would have to multiply x by 4x in order to get 4x squared. Take the 4x, multiply it back by your divisor, so 4x squared, and then 4x times -1 is -4x. We're subtracting this from the one above, which changes the sign of each term, so that goes to 0. So I have 4x, and then I bring down my -4. Look at the first term here again with 4x. What do I have to multiply x by to get 4x? And that is a 4, so I would add 4. 4 times x is 4x. 4 times -1 is -4. Subtract them off, which gives us negative here and positive here. So everything goes to 0. So that means we just don't have a remainder. So our answer is just x squared plus 4x plus 4. All right, guys, go ahead and give some of those a try. You're going to print off the worksheet called 2.3 Polynomial Division, and then you're just doing the front side for today. Tomorrow we'll go over synthetic division, and then you can do the back. All right, guys, good luck. Email me if you have any questions. Bye.